Good morning, everyone. I hope you people are doing very well. In yesterday's class, we have learned about creation of data frames and introduction to data frames. Today, we are going further, and our next topic is data frame attributes. What is an attribute? Attribute are the properties of any object. Okay. In case of data frame, we can say that the attributes are those functions or those labels which are giving us the information about that data frame. Here we are having few attributes like index, which is giving us information about the rows, columns giving us information about the column labels, axis giving us a list about both the axis, that is 0 and 1. Data types provide us the data types of the data in the data frame. Size presents us the total number of elements. Shape gives us a tuple, which represents a dimension of that object. Endem is the number of dimension, and we all know that data frame is a two-dimensional object, so by default in every data frame it is always 2. But if we are creating a 1D data frame, then it is 1. In empty, it indicates whether the data frame is empty or not. It always gives the result in the form of a boolean value, that is either true or false. If we are having any value in the data frame, then it will give the result as true, else it will give the result as false. Next one, we are having transpose, which is changing index into column and column into index. Next, count, which is returning the known NaN values, and next one is values, which is representing the numpy representation of the data frame. Now we are going to study about these attributes one by one. First, I'm taking an example of a data frame and I'm creating the data frame from dictionary. So first, I'm importing the libraries by import command. Import numpy as np. So the nomenclature for numpy is np, and for pandas it is pd. Fine. Now I'm creating a dictionary dic1 in which I'm taking keys as students, marks, and sport. See children, here I am giving NaN as a value which belongs to the numpy library. That's why I have imported the library numpy as np, because NaN, not a number, belongs to numpy library. Fine. Now df1, my data frame object is df1, and I'm passing this dictionary object over here in the data frame function to create the data frame, and I'm printing my data frame. Now this is the output which I am getting from after printing my data frame. Since we all know that data frame is a two-dimensional structure and it always presents the output in the form of a tabular format. Now I am not specializing or giving any index over here, so by default I am getting the indexes as 0, 1, 2, 3 and 4, and my column names are students, marks, and sports. So rows are always on the axis 0 and column is always on the axis 1. So till now we have created the data frame df1. So we are moving further on the attributes. First one, my first attribute was index, which is giving us the row labels. So my format, the command to write a attribute is df1, that is a data frame name, dot index. Index is my attribute name. First you have to write the name of the data frame object, which is my df1. Then you have to write the dot or the membership operator. After that you have to write the attribute name. It is giving me the output as range index, which is starting at 0, stopping at 5, and a step is of 1. Now in my next attribute I am having the attribute of columns, which is giving me the name of columns or the column labels. Here I am getting the output as index and all the names of the columns, students, marks, and sport, and my data type is object because these are having the data type object. Next one is axis. Axis is the combination, you can say it's a combination of index as well as columns, because it is giving the list representing both in rows and columns. First it is giving the output of rows, that is the range index, start equal to 0, stop equal to 5, step is equal to 1. 0 because the index is starting at 0, stopping at 5 because we are having 5 rows, 0 to 4. After that it is taking the step of 1. After this we are having the details of columns, that is we are having 3 columns over here, students, marks, and sport, which is having a data type object. After that, if I want to find data types of each column, or you can say that of which kind of data they are storing in every column, so we are having the attribute name as D types. So students are having object, because in this we are having names. After that we are having marks, which is in the float 64. Now the question arises, ma'am, we have given the numbers in the form of integers, but we are getting the result in the form of float. Why? Because children, we are using NaN here. Okay, and NaN means it's an unspecified value. It can be anything. So float is always having the larger memory than the then integer, and by default the data type of NaN is float 64. That's why we are having data type over here as float 64. Next sport we are having object, and last their data type is object. Till now we have learned about the 4 attributes. One is index, giving us the row labels. Next one is column, giving us the column name. Next one is access, returning the list representation of both index and columns. Next one is D types, which is giving us the data types of all the columns. Now moving further, we are having size, df1 dot size. I already told you that size gives us a total number of elements in the data frame. Now how can we calculate the total number of elements? By simple method we can say that row into column. If I am doing that row into column, then I will get the total number of elements. How many rows we are having? 5, as it is going to 0 to 4. So I am having total 5 rows over here. And how many columns I am having? I am having 3 columns. So 5 into 3 is equal to 15. Okay, you can count it over here. We are having 15 data over here in the data frame. Next one, shape. Shape gives us the representation of dimension in the form of tuples, that is row into column, 5, 3. Okay, if we are multiplying the shape, then we will get the size in this one. Next one, we are having n dimension, and I already told you df1 is a 2 dimension, because we are having both x and y axis over here, or you can say the axis 0 and axis 1. Now this is another attribute, len df1. As we all know that len is a by default built-in function of Python. It gives us the length of data frame. Okay, length means number of rows in a data frame. We are having 5 rows, so that's why it is giving us the value 5. Next one, empty. As I told you already that it gives us a boolean value always. If our data frame is empty, then it will gives us true, else it will gives us false. Next one is values. It gives a numpy representation of our data frame, means in numpy how we are storing our data frame. In numpy, as we all know that it stores a value in the form of array, so it is storing first value, then second, then third in the form of rows. Okay, now moving on towards our next attributes, it is transpose. In transpose, told you that rows become columns and columns become rows. You can see over here, when we are printing our data frame earlier, then we are having rows labels as 0, 1, 2, 3 and 4, and columns as students, marks and sport. Whereas in transpose, our columns become the rows and our rows becomes the columns. So this is transpose. That means converting row into columns and columns into rows. Now we are having one more important attributes, that is count. This giving us non-NaN values, means if any row or any column is having a not a number value, then it will not give that value. It will not count that value in that data frame. Now as I told you, 0 is x is 0. That means it counts the values according to rows. In students, I am having 5 values, right? You can count it over here. See, in students, all the values are fixed: Aman, Ayan, Trisha, Manaswi and Hina. But in case of marks, only 4 students are having their marks and 1 is not having the marks. That means it is having a NaN value, and count always gives us the non-NaN values. In sport, we are having all the sports, so we are having 5 over here. Now in output, we are its data type is int64. Why it is int64? Because it is counting the values. The output we are getting, it is an integer. Same case in df1.count, that is 1. That means it is counting according to the columns. it was counting according to the rows and it is counting according to the columns. Okay, so in first row we are having all the 3. In second one we are also having 3, 3, 3. In last one we are only having 2 values. In that, in count 0 it is calculating on number of rows. Okay, right, 1, 2, 3, 4, 5. It is counting according to the rows, and in 1 it is counting according to the columns. Okay, so don't get confused in these. Create a data frame for your class which is having column indexes as name, age, marks obtained, maximum marks, percent and grade. After that you have to enter a missing marker in the data frame. Okay, while creating a data frame, since I told you in the earlier example, you can directly enter the missing marker while creating the data frame, that is NaN. After that you can display the x's, row index and column names in your output. After that you have to apply all the data frames, all the attributes on the data frame created above, and you have to show the result to me. Now moving on towards our next topic, which is operations on rows and column. Our first operation in our syllabus is selection. How we are going to access or select a particular row or column. So first one, I am selecting a column, a single column. So I can write over here first data frame object, that is df1 dot student. Students is the name of column. The column which I want to access is student. We are having 2 methods over here. Either you can use a membership operator and directly write down the name of column, or you can write the name of data frame and square bracket. After that you can write the name of column. Both the methods are correct. While using a membership operator, you are not allowed to write it in the apostrophes. In only the square bracket method you can write it. So here we are having the output, only we are having the student's name or the student's column. Next one, if I want to access multiple columns, then I am having the method like this. If you are doing it by this, it will give you an error because it already recognizes this first one. Okay, so if we want to access the multiple columns, we have to write in this way: your object name df1 first bracket, then second. After that your name of the columns, how many columns you want, you can write it continuously after making comma, then close that bracket and again close that bracket. Okay, and in this way you get the output of these 2 columns. So for accessing a single column, you can do it by any of the methods, and for accessing multiple columns you can use this method. Next one, selecting a single value means only a single value. For suppose I want to write Trisha. Okay, I want to access only the value name Trisha. So how I can write it? I am writing it df1 my data frame name in any of the method. First you have to write the data frame name. Okay, after that you have to use the dot operator in all the methods. Okay, next one, you are selecting column name and then row index. Column name and row index, that means in student column second row. Okay, same case in this. Instead using this, you can use the at function, the at operator in this row column. Okay, second row student column. Fine, second row means index label second. Now next one, index at. If you are using index at IAT, I means index, so in square brackets we are going to give the index of that row and column. So here the index is 0, 1, 2. Okay, 2 index and it is 0 and 1, so our index is 2, 0. All of these gives the value Trisha. For suppose if I want to access Manaswi, then I have to write students over here, and in bracket I have to write the index, that is 3. Okay, same case if I want to use this command, then I have to write 3, that is a row comma student. Okay, and if I want to use this, then I have to write 3, 0. If I want to check according to the index, then I have to use I at always, that means index it. And if I want to directly use the rows and column names, then I can use it. And if I want to do it with the help of column, then first you have to write the column name, then you have to write the row number. Now next thing, selecting a rows or accessing a row. Accessing a single row. If I want to access a single row, then I have to write data frame name dot LOC. LOC means location of that row. After that, which row you want to access. Okay, and there's a syntax over here. First you have to write the data frame name dot LOC. After that, you have to write your row index, comma, your start column, colon, your ending column. Since I am taking all the columns, so I am using blank over here. Okay, I am not using any letter over here. We have learned about this in slicing while doing the list and dictionaries. Okay, so this is one is slicing operator. So I am using start column is 0 and end column is 2. So I am getting the first row only. First row was of Ayan, where student name is Ayan, marks is 80, sport is tennis. Okay, name first, index of the column is 1 because I am giving the index over here 1, and data type is object. Now next one, accessing multiple rows. While accessing multiple rows, we are having next one, df1, same case as above one, data frame object, location, from which starting row, from which you want to start your starting row index, your ending row index, your starting column index, and your ending column index. Okay, so this is the syntax. First your starting row index, then your ending row index, then your starting column index, then your ending column index. So over here I am taking 1, 2, 3. So I am taking the rows as first row, second row and third row. Okay, after that I am taking all the columns. So it is coming over here, student, marks and sports. Now in the next one, I am selecting multiple row and multiple columns. Till now I was selecting only single column, multiple column, a single value, right? After that I selected single row and multiple rows. Now I am going to select multiple row and multiple columns. First by names, I am giving it df1.loc. It is always as a location. Why it is 1, 2, 3? Because our index labels are by default 0 to 4. So I am giving over here 1, 2, 3. These are the names. Keep this thing in mind. It is a name. If it is ABC, then what should I write? I write over here A to C. Okay. After that my columns name are student and marks. So it is student and marks. Now if you want to print only student sports, it will not be there because it is a continuous one. Okay. Now by index, we are having 1, 2, 3, and for index we are using iloc. Keep this thing in your mind. While we are accessing the value, I was using IAT, that is index at. Here by accessing a single value, I was using IAT, that is index at. Now I am using iloc, that is index at location. Index at location. So I am giving the index starting till end. It will not include 3 because it is using the index. So it was giving me the index is 1 and 2, and my column is 0 to 1. That means it is not including this one. It will, as we all know that slicing operator doesn't include the last value, so it is only giving me the first column, that is 0, 1 students. Okay, till now we have learned about the selection, selecting a single column, selecting multiple columns, accessing a single value, then single row, multiple rows, multiple row and multiple columns. After that we are going through addition. First, adding a column with a single value. Single value means the complete column is having the same value. Here I'm adding a single column. First I'm using a data frame object df1. I'm putting a square bracket. I'm adding the next column name atten, ending the bracket. I'm giving the value 90. Here I'm adding the column attendance and I'm giving single value 90. So we see over here we are having one more column attendance and all the values in the column is 90. Okay, now I want to add the same column but different values. I don't want that every attendance is 90. Okay, so what I have to do, I have to add it with the form of list. Okay, here I'm giving the values in the form of list: 90, 89, 95, 89, 79. I think all of you have noticed the change over here. I'm giving the single value, it is entering the single value all over the data frame. But if I'm giving the value in the form of list, then it gives the value in or the data frame over here like this. Okay, so in addition, first thing, you can add a column with a single value. You can add a column with the different values. If you want to add a column with different values, you can use the list method. Okay, next one, adding a row with single value. If I want to add a row with single value, so I'm putting over here, okay, data frame name dot where you want to add the value, that is it at. Okay, your row index which is not there. Okay, next one, start column to end column. This is start column to end column. That means the complete row is having the same value and I'm giving the value as 98. Now I'm printing my data frame. You can see over here your index is 5 that we have given. Okay, and start column till end column, the value is 98. So it is taking it 98 as a string, it is taking 98.0 as float, it is taking it as a string, and then it is taking it as float. Because of this the complete attendance will become the float. Now next one, modifying a single value. What I'm doing, I don't want 98 over here. I think there should be a name over here. So what I am doing, df1 my data frame name dot at, that means at which index, 5, because I want to change the name 5, where at initial column 0 to 1, as it is not including this one. Okay, I'm giving the name over here Krishna. After printing my data frame, I'm getting result as 5 Krishna. In the same case, you can modify the values over here. There are other methods also by using the append function, other things, but it is not your syllabus, so that's why I'm not telling you over here. Okay children, thank you everyone, and tomorrow onwards we will discussing about further operations.